All right, this last type of problem is probably my favorite type of problem um, because it deals with, a very much a geometry concept of solids of revolution. And again, for those of you going to calculus, you'll see solids of a revolution a lot next year as well. So we have a rectangle, and what we're told about this rectangle is that the perimeter is 12 inches. Okay, so that's what we know. And then it also tells us that we're going to form a cylinder by revolving the rectangle about one of its edges, right? So this arrow here means we're going to take this rectangle and we're going to rotate it around. So if you can imagine sweeping the rectangle around, it's going to sweep out the shape of a cylinder. This is hard to demonstrate in two-dimensional space, but if you want to just literally take a piece of paper and swing it around like one of its edges, you'll see that it sweeps out a cylinder, right? And so that cylinder is going to look something like this. If I were to draw it, right, it's going to be fat and short, right? Oh, I didn't do a very good job of drawing it. Right, it's going to be like that. Okay, so the rectangle we're looking at right here, right, is in here. This is the rectangle we're looking at. And then when it sweeps out that cylinder, we now have a three-dimensional shape. Okay, I intentionally kept these lines here. Okay, I did intentionally keep those lines there for a reason. Okay, so an equation for the perimeter, well, we know that the perimeter is 12 inches of the rectangle. And we also know that the rectangle is x by y. So this one's pretty easy. 2x plus 2y is going to give us our perimeter. It doesn't say anything about, in terms of x or anything like that. So we're going to just leave it as 2x plus 2y for right now. And then it says write a formula for the volume of the cylinder in terms of x. Okay, and it reminds us that the volume of a cylinder is pi r squared h. So this is the volume of a cylinder. Right, so now we need to think, well, how does r and h relate to my rectangle? So it says in terms of x, but before I do it in terms of x, let's think about it in terms of x and y. Okay, so the r of my cylinder, right? Here's my cylinder. This is the r of my cylinder. Well, how does that translate to what I'm looking at in my rectangle? Well, r of my cylinder is actually x on my rectangle. Okay, so volume, I'm going to replace the r with an x, right? Because r of my cylinder is x of my rectangle. And now what's the height? Okay, if I look at the height of my cylinder, well, the height is really y from my rectangle. Right, so pi x squared y is going to give me the volume of my cylinder. This is in terms of x and y. We want it just in terms of x. So that's when we're going to go back up here, right, to our perimeter equation, and we're going to solve for y and substitute. Right, so solve for y. So we can do that out here. I'm going to actually start just by dividing everything by 2. We get x plus y is equal to 6, and therefore if we isolate y, y is equal to 6 minus x. So now I can take this expression for y and substitute it right in here into my volume formula. So the volume in terms of x is pi x squared times 6 minus x. Okay, part C asks us for a reasonable domain. And so now let's think for a second what this function is going to look like. All right, we have an x squared and we have a negative x here. So this is actually going to be a third degree polynomial, the negative lead coefficient. It's going to look something like this. And it's going to have zeros at 0. Right? We've got an x squared, so it's going to have a double root actually at 0. And then it's also going to have a 0 at 6. So if we think about the context of the problem, right, our reasonable domain here is going to be 0 to 6, because if I know that x plus y equals 6, and I make x, if I make x 6, then y is 0. So there is no y dimension of this rectangle, so that doesn't make any sense. But I can go all the way up to, let's say, 5.99, and then have a very small sliver for y, and still have, a rectangle there. Okay, so our reasonable domain is going to be 0 to 6. And we can now go take a look at what the graph of this looks like. Okay, so here we see the graph of pi x squared times 6 minus x, and as we predicted, we see a polynomial with a negative lead coefficient. It has a double zero, right, a tangent 0 at 0, or a double root at 0. It has another root at 6. And we're looking for the maximum volume of this cylinder. So it looks like it's going to be right there at 4 comma 32 pi. So 32 pi, and we can multiply that out and kind of see what that is. It's going to be a little less than 100. So 32 pi is the maximum volume of this cylinder when it rotates around its end, and that's going to occur when the radius of the cylinder is 4. So again, our maximum volume is 32 pi, and you can multiply that out. Your calculator will give you an approximation for it, but it's something, 32 times 3 is 96, so it's going to be somewhere between 96 and 100, I would guess. And then the x value, or the dimensions of the rectangle, I think we're pretty dimensions of the rectangle that give us that volume. So x would have to be 4, and if x is 4, then we know that y is 2, and I believe this is inches, right? Yeah, inches, and our volume is in cubic inches. And that x value is also the radius of your cylinder, of course, and the y being the height of your cylinder.